Welcome. Rust has been voted programmers' favorite programming language in the Stack Overflow developer survey for 7 years in a row. Hi, my name is Tim McNamara. I am a software engineer. My job is actually to support builders inside Amazon with Rust. I'm really excited to be able to share some of the lessons that we've learned to be able to kind of assist you with that decision-making process for your own workplaces. I want to start, though, with a bit of a sad story, and that is the sad story about software development. Software is hard to write. It's very, very hard to write well. This leads to unreliable software. It's very common that people delay updates because they're just a little bit concerned that things will break. We actually expect, as an industry, that data breaches will happen. Like, for our users and customers, this shouldn't actually be an acceptable state of affairs. Moreover, we use a lot of energy to deliver the services that we do to our customers. Our web APIs probably consume a little bit more energy, a little bit more memory than we would like, maybe a little bit more CPU usage than we probably would prefer. Rust is a programming language that isn't the perfect solution. It's just software. But it is a good step forward, and I'm hopeful that I can kind of keep your attention for a few minutes, at least, to be able to describe some of its distinguishing characteristics, which have shown to provide meaningful impact for removing response times, especially at the tail end for tail end latencies, and also reducing memory consumption. So we can describe programming languages in kind of two spectra, or two axes. The y-axis and the vertical might be control, and along the x-axis is safety. Historically, we've had to choose. Do we choose a language that provides full control, or do we choose a language that provides full safety? So you might go for a C++ and ask, I want peak performance. Or I might go on the other side and say, I want a Python because I don't really care about how things are implemented internally. All I want is my application not to break because of some crazy sig fault or something like that. Rust kind of breaks out of this and provides both. Its distinguishing characteristic is that it enables you as a developer to have both complete control over memory layout while maintaining complete safety. And it does this without a garbage collector, without a runtime. There is no JVM sitting alongside your application, kind of hogging resources or managing objects, because all of those safety checks occur at compile time. Now, there are probably some software developers in this room who might be interested in knowing, like, what does this thing actually look like? So here is a function that computes the sum of squares of some iterable of i32 integer values. It takes as a reference the square thing means a slice of i32. This is an integer that is 32 bits wide and returns their sum. It does that by creating iterator over itself, applying an anonymous function or a lambda function to every item, which computes each item's square, and then the sum method there will take the iterator that has been created by map and accumulate the sum. Idiomatic Rust uses a very functional style, and so if you are a fan of functional programming and declarative programming, you are actually going to feel pretty at home here in Rustland. Oh, okay, so the question is, tell me about this ampersand. What on earth is that? That is a read, as a Rust programmer would read that as a read-only reference to some slice. It isn't, so the question is like, this is performing some side effect. It isn't actually a function in the pure functional style. I would respond the fact that we're actually not performing a copy or a mutation of the input data. And in fact, we're guaranteed that we cannot mutate the input. We're only taking a read-only reference, and so we're actually not allowed to mutate that thing that we have a pointer back to. In memory, it's implemented as a pointer. Rust isn't completely isn't puritanical about being a functional language. It is definitely a blend of imperative and functional styles. But I would say, in the general case, a functional style is kind of the idiomatic way to write code. The question, though, is, well, OK, that's fine, but this is only going to work very, very quickly across one core. We've got multi-core machines. How do we make use of the whole capability of our hardware? And I would like to just introduce you to a one-line change. I can import a third-party library, which extends the slice to provide it with a parallel iterator. This will do all of the busy work of creating creating threads to be able to make use of all of the CPU cores, apply this computation in parallel, and then join everything at the end. Not all concurrency or parallelism tasks are going to be this easy, but for data parallelism, which Rayon provides, typically this is all you need to do. You can have the complete performance of your computer without needing to get kind of really frustrated with kind of horrible syntax and a lot of boilerplate that you might be used to when you're kind of dealing with threads. I will pause you there just because we've got questions at the end. My next example is slightly more complex. What we're doing is taking some input text, and we are returning a hash map, or if you're, say, a Python programmer, we'll call it a dictionary, of a count of the number of times that a word appears in the input text. We do this by initializing our counts hash map, iterating, and then calling split whitespace, which is, by the way, Unicode aware. The string or str data type is guaranteed to be UTF-8 encoded. We then manipulate that word, in a sense, by trimming any non-alphabetic characters. So this will remove punctuation. It's a relatively basic natural language processing task. And then we ask the counts hash map, do you contain this word already? And if you don't, give me a 0. That's what the default value is for the U32 data type that is defined in the return value, or the return type signature. That gives us it actually gives us a mutable pointer, which we then dereference and increment. I want to point out a few things that are slightly subtle. Our input text requires a read-only reference to some UTF-8 bytes. Rust will guarantee that no other thread or no other part of the program will interfere with text while we are doing this processing. You will not have a case in which mutation will occur behind the scenes. Moreover, we do not copy any words here. There are no allocations in this process. It is extremely highly performant. The internal details of the hash map is that the references inside that hash map and the keys will actually be referring back to the same data that text is referring to, just in different parts of, it will just take its own little subslices of that input text. This, however, provides a little bit of a problem if you are coming from other languages. The problem is that now your hash map is kind of somehow bound to the lifetime of the input string. You can't touch it because what if the input string goes away? And that is where programming in Rust becomes difficult because objects are kind of tied to each other and their lifetimes are bound. In practice, this generates significantly more robust code. You cannot create a situation in which you have a reference to some other object which might disappear. That can't happen. Now, we've got one serious example. I thought also we should kind of figure out how to implement FizzBuzz as a group, because we all need to get our entry-level coding example, our coding interview kind of sussed. So here is one way of implementing FizzBuzz in Rust. We go from elements 1 through 100 inclusive with that dot equals syntax. This gives us an I, which we then divide and check for its remainder. This is the modulus operator that you probably have already seen. Does this divide by 3? Does this divide by 5? And then we match. When we have no remainder on either side, we print FizzBuzz, and as you can see, we go all the way through. And this is just a very subtle hint about how powerful pattern matching can actually be. It's a wonderful system that you will really beg for in other programming languages. Speaking as someone who learned to program in Python and spent many years programming in it, I dearly miss pattern matching when I code in that language. There are some programs that actually you cannot write in Rust. As I've sort of hinted upon with that hash map example, Rust is more strict. So if you ever started to learn to program, you might have encountered a syntax error related to the fact that equality is distinct from assignment in most programming languages. And if you started your programming world in C, what you're attempting to do here is check, is A equal to 24? But we're actually converting an assignment, and therefore we have a bug here. And this is ostensibly a bug with the programmer. But that isn't especially helpful for beginners. Rust will fail to compile this program because of it will fail the type check whenever you whenever you have an if expression in Rust, it requires a Boolean operand, and therefore the assignment in Rust doesn't return a Boolean, and therefore you'll be guaranteed never to encounter this problem in Rust. Here's an example from Java. We create an array list. This is kind of a growable list, initialized to no contents, and then we start inserting some numbers. Towards the end, we iterate through our array list and start asking questions about it. In particular, we want to be able to see if we can modify the list as we're iterating over it. Java-C will compile this program, and it will blow up on you at runtime. The problem here is that we're attempting to effectively modify the list while we're iterating over it, and we're kind of in this impossible situation where the iterator, it's called iterator invalidation. This will never happen in Rust. All of your iterators are guaranteed to work exactly as they're intended. An example from JavaScript. So JavaScript, a set object from, if you're in computer science world, is a data type which eliminates duplicates. Now, if I were to ask you how many duplicates are in this set, or sorry, how many times does the object ID 123 exist in my set, the intuitive answer is to say, well, actually, it should only appear once. it appears twice. And this is because of the way that objects are implemented. Rust will require you to opt into the semantics that you require. If your program demands that the memory address or the pointer equality is what determines uniqueness, then you can use that in your sets. However, if you want to require that the values of the contents of all of your containers are what matters for equality, then you choose that option. If you decide to ignore the problem, Rust will blow up at compile time and say, dear programmer, please tell me. And that is one of the reasons why people get annoyed with Rust, because it's slightly pedantic. It's fussy. The compiler is trying to be your friend by guiding you away from situations that are unclear. One final example. This is from Go. I don't mean to pick on Go, but here we have hello world kind of concurrently. So what we've got here is hello, a map being initialized with world, and the question is, and then I spawn two Go routines. One assigns world and to replace it with Tim, and the other one replaces it with Tom. And the question is, when we go to print hello, name, what will it print out? And the answer is probably hello world, but it is completely non-deterministic. This is up to the scheduler inside the Go runtime. This type of bug cannot occur in Rust. You can't get into a situation where different parts of your program are confused about who has responsibility for, who has right access to my data. So this is a little bit of an introduction to, well, this is kind of the overview of Rust. I'm hopeful that you can kind of get a bit of an understanding about how it operates. The next section is, why is this thing actually interesting? So my short answer is that it eliminates memory safety by design. Say, well, what is memory safety? Is this even a problem? Tim, come on. It turns out that there are a multitude of security researchers through some of the world's largest companies and sort of peak software engineering companies that have detected that about 70%, roughly between 60 and 90% of their high or severe CVEs are related to memory safety bugs. If you go and check which vendors have patched CVEs and then go check how they're categorized, we can see that this is slightly ubiquitous throughout the industry. This is a class of error that is impossible to actually create if you program in Rust. It's just eliminated by design. But that's not all. My personal belief is that Rust actually empowers your teams. It's a really enabling technology. With this kind of, you know that the guardrails are in place, that you won't get yourself into weird kind of corner cases. You can actually have the confidence to implement new technologies, really novel stuff. By the way, you actually get even more performance. You cannot ever encounter like a null pointer exception or a null reference exception if you're in C#, because null pointers don't exist in the language. The functional paradigm that we touched on earlier is becoming more and more commonplace, and Rust is a relatively late comer in the programming ecosystem, has been able to make use of more techniques and styles that developers prefer to program in. It's impossible to just decide today, I'm not going to worry about that error. It'll never happen. The Rust compiler would sort of sit you down and say, sorry, Tim, I really need you to deal with that case. and I'm not going to let your program compile unless you do so. The question is, but I kind of need some more evidence. Like, I'm trying to evaluate this, and none of this kind of safety stuff matters. But what might matter is the responsiveness to customers. Our experience has been that we can reduce the median latency as well as the P99.999 latency by significant amounts and almost universally across all the services, web services that have deployed significant components with Rust. Additionally, if you, for example, use Rust in like a Lambda context, in particular in comparison to, say, a Java, a Rust container might be about, like, say, between 50 and 100 megabytes. A Java container for the equivalent workload might be like looking at in the gigabytes in terms of size. And so that actually reduces the friction for your ops teams just by the fact that Rust doesn't require a runtime. It doesn't need a JVM. We've talked a lot about the safety features of Rust. And I wish to reiterate one thing, though, is that all of those safety features come without a performance penalty. The downside is that they come at development time. You kind of need to feel the pain earlier. And so my view is that Rust can actually feel kind of pedantic and fussy and a little bit irritating. And if you're sort of scripting, it's going to just feel irritating. Your customers will benefit, but kind of you in the moment might not. There will be times in which you require a different mental model for your programs. We've talked a little bit about how when I had that hash map, my keys were actually tied back to the data that was provided at the input text. And so you actually need to really think about how your program is laid out. In particular, Rust finds working in undirected graphs really tricky. If you have a doubly linked list, this is a sort of an elementary data structure that is impossible, I believe, probably going to be corrected, but let's say impossible to actually implement in safe Rust. Lastly, the learning curve is a problem. So the Rust community carries out an annual survey, and some of the people who have left Rust still respond to the survey because they believe in it, and then they get asked, well, why did you leave? The majority, or the small majority of the people who have left have done so because the learning curve was too steep. My response to that, as someone who learned Python, is that this problem is real, but it is surmountable. Give yourself the time to learn Rust, to kind of cut with the grain instead of against the grain. There are programs that you will no longer be able to write because Rust is more strict. Yes, you will be irritated, but yes, you will get through, and your customers and your users are going to benefit. Okay, I just want to chat a little bit. I've got some external customer reviews, as well as a couple of examples from inside AWS about what it's like to deploy a Rust application. So Tenable decided that they were spending significantly more on compute than they wanted, so they would kind of give Rust a go and see if it actually lived up to the claims that it's making. They were able to eliminate 300 CPUs from their appliance while providing an even faster proxy that they had actually implemented previously in JavaScript. I believe it was Node.js, but do dig into the blog post for further details. A really good use case for Rust is Lambda. And you can see this graph shows that we can use a Lambda instance that is 1/4 the size of, say, a Go or a Node.js, but actually get faster performance. To deliver 2.5 billion executions, we can save cache. This actually results, by the way, in your customers being able to receive responses faster. Just a small shout out onto the Rust website. There are a couple of really useful white papers in there. One of them is from a startup called Tilda, and they run a service that has a client that sits inside, sort of a daemon that sits inside their client's instances or their client's servers, and that sends back information to some sort of metric server that they control. They were encountering genuine issues with their initial implementation in a dynamic language because it turns out that their customers were deploying to Heroku, and they would reach memory caps and then the instances were being turned off. And this was a real problem if you're trying to convince someone to use their service. They were able to reduce the memory consumption from over 100 megs down to 8. And on the server side, it's almost more dramatic. Their server instance required 5 gigs of RAM, just steady state, but their Rust implementation went down to 50 megs. AWS itself and the rest of Amazon are big believers in Rust. I want to talk a little bit about CloudFront. So CloudFront had increasingly been asked for HTTP3 support. The response from AWS was to provide a library called S2N-Quick so an open source quick implementation in Rust that actually now drives all of CloudFront's HTTP3. The Firecracker micro VM open source project sits underneath Fargate and Lambda. It enables us to spin up isolated micro virtual machines in milliseconds and supply, or at least support, trillions of requests per month. The blog post, by the way, the link actually is a white paper that research paper that describes actually how they work internally. It's kind of cool if you like geeking out on this stuff, so I would really encourage you to kind of dig deep and have a look through. From the broader Amazon, you start to encounter, so me as someone in AWS, you start to encounter more and more embedded work cases. The Prime Video client, the thing that sits on your TV or runs on your smart TV, is actually written in Rust, compiled to WebAssembly. The team needs to support at least 8,000 different device types. And that's everything from computers that are just kind of sit in your hand, all the way to kind of as big as you get, desktop machines. So there was a real need to improve on the status quo because some of these little devices really couldn't keep up, or we really couldn't provide a very good customer experience. But those problems, the performance problems that our customers were facing, have really kind of gone away. We can see this in, for example, like complaint metrics and so forth. And this has been enabled by Rust. Lastly, I wanted to just provide just a glimpse into S3. So the S3 team, or the S3, bigger than one team actually, it's quite a few teams, have been for years and years and years trying to really optimize two APIs, right? Get and put. I guess delete as well. The post that I've linked to is, again, to a research paper that describes the implementation of ShardStore, which is a new storage node backend implemented in Rust. And the thing that I want to touch on isn't just the increased performance and throughput we can drive with this new service or this new implementation. It's actually the work that some of the kind of auxiliary teams have put in to really test this thing in terms of being able to apply lightweight formal verification. So if you work in the Rust space, you'll notice that there is what we call you may have heard of formal verification as kind of the next step after testing. We formally verify that our software is mathematically correct by applying provers and solvers and so forth. This is typically done in very, very sensitive applications where performance is, or at least security requirements are exceptionally high because it's a very expensive process. It's really hard to verify your software. AWS has sponsored some open source packages, particularly the Kani model checker, but there are some other open source projects that you'll see if you dig deep through that post, which actually enable even application teams, people who have never worked with formal verifiers, to be able to access these tools by using like a Rust DSL, which I find really, really neat. If you're interested in this thing, there's kind of two places that I really wish to send you. One is open source, the open source GitHub page. You'll notice that two of the headline projects are written in Rust, BottleRocket and Firecracker. And the other one is the AWS Developer Center. Rust just appeared this year, a couple of weeks ago, as a first-class member of the Developer Center, and we have a whole bunch of resources there available for you if you want to kind of use the Rust SDK for AWS, the Rust runtime for Lambda, and so forth. And I encourage you to kind of like have a bit of a peek. There are also a large number of resources about Rust, the language, publicly available. If you are the project lead for the kernel of the world's most popular, most heavily used operating system in the world, the threshold for introducing a new programming language is quite high. Rust has actually this year been sort of accepted into the mainline, and I want to spend sort of several minutes actually chatting about some strategies for like giving this a go at work, or maybe even at home. Our experience has been that, so inside AWS and the rest of Amazon, teams actually choose their stack. Every team makes a call about the technology choices that they are going to use. And so the thinking process that you're going through is the same thinking process that our teams go through. The way that things typically work is that someone will tinker for a couple of years on this Rust thing, and they'll kind of give an internal talk, and will then be told, okay, prove it. My recommendation to you would be to find some service that is well understood, that you could write in, say, Ruby or JavaScript or whatever you'd like in like a day or two. And then give yourself a week to implement that in Rust. Find out, try and get approval to carve out some time to provide yourself the space to write a prototype. And then put it to work. The important thing to note is that you really want a project where you have a good understanding about the inputs that the thing it detects, or you want a good understanding of the business logic that it needs to implement. So a really nice use case is Lambda. If you have a Lambda function, we can kind of swap this out, and if things don't fly, you can just kind of leave them as is and say, sorry, Rust, you'll need to prove yourself next year. what you will find is as soon as you implement that proof of concept, there will be more interest, and there will be kind of an increased willingness to experiment, and you will be the person who is asked for advice. I don't mean that to intimidate anyone in this room or anyone watching the recording. What I mean is if you're the kind of person to watch the talks about this thing, you're kind of likely to be the person who someone is going to ping you and say, hey, look, how does this work? And so be prepared for that. The other thing that I would encourage you to do is be prepared to be frustrated. Again, Rust is stricter than other programming languages. It does that for good reasons. It's not trying to constrain you. It's trying to kind of point out that patterns that you used to program in aren't actually safe. They cause bugs. Well, they are bugs. And if you kind of go in a different direction, like the Rust way, your customers will be happier, your users will be happier, and your own service will be more stable. But I can't answer the question, is this thing useful for me? Like, is it worth it in the general case? I can give you a couple of tools, like implement the prototype of a service that is kind of using a little bit too many where there's a pain internally, and build from that. Build your own confidence and build your team's confidence. Don't come out and say, okay, we're just going to implement the core application in Rust, because you're not going to get anywhere. But I hope that you get somewhere. I have several minutes left for questions, but I would like to thank you all for attending the session. And with that, I should wrap up. Thanks.